Hello everyone, today we are here to do an experiment. What is the aim of this experiment? Finding the image distance for varying object distance in case of a convex and drawing corresponding ray diagram to show the nature of the image formed by it. Okay. Now let's discuss some theory related to this experiment. Here we will use convex lens. Convex lens is also known as a converging lens. Why it is known as a converging lens? Because if the parallel beam of light fall on the convex lens, then it converges all the rays at one point. That one point is known as the focus for that lens. Okay. Now come to the activity. To do this activity, I require some material. What are that materials? I require a convex lens whose focal length is 20 centimeter. Okay. I require a source of light which I will use here, candle, a matchstick, a white sheet that I use as screen, a lens holder. Okay. Here I have taken one white sheet on which I have marked some point. This is a point where I will place my lens. Okay, so this point will represent as the optical center for me. From the optical center, the 20 centimeter, that is the focal length for it, I will get the focus. So this is my focus, and this distance is double to the focus, means from the optical center to f(1), the distance is 40 centimeter. Okay, and here the distance is more than 40 centimeter. Similarly, on the other side, I have also marked point at the distance 20 centimeter and at the distance 40 centimeter. Okay, now let's start the activity. To do this activity, I am placing my lens holder at the position of the lens. Now I will place the lens in the lens holder. Now I will burn the candle because it will act like the source for us. Here we want to prove that if we change the position of the source of the light, then the position of the image also changes. Okay. Now first of all, I am placing my source very far away from the lens. Now I have placed my source of the light very far away from the optical center, and I will try to take the image on my screen. Okay, to show you the image very clearly, and now I am going to dim the light so that the image will be very clear to you. Now see, this is my image. Okay, if I am changing the position of the screen, the image will be not on my screen. Now if my screen is at the position f(2), means at the distance 20 centimeter from the optical center, only then the image is clear on the screen. This image is very small in size. Because this image can be taken on the screen, so that's why it is a type of real image. This shows that when the object is placed very far away from the optical center, or you can say that the object is at the infinity, then its image, its real image will be formed at the focus. Okay, and that image is of very small in size. Now we change the position of the object. Now what we do, we are taking our object closer to the optical center. Now I have placed my object beyond the 2F1. Now I will adjust my screen to get the clear image. If my screen is here, there is no image on the screen, but if I am taking my screen closer to lens, then at this point I will get the clear image. To show you clear, now I am again going to dim the light. See, this is the inverted image, this is the real image, it is diminished image, okay, and it is forming between F2 and 2F2. It means when our object is beyond 2F1, then its image is formed between F2 and 2F2. It is real, inverted and diminished. Okay. Now next, again change the position of the object. Now I am placing the object at 2F1. Okay. Again I am changing the position of the screen to get the clear image. Now see, when my object is at 2F1 distance, then its image is formed at 2F2. It is real, inverted and of the same size of our object and at 2F2. Okay. Now again change the position of the source of the light. Now I am placing my object between 2F1 and F1. Okay. Now I am again changing the position of the screen to get the clear image. At this point I am getting the clear image on the screen. Now see, the image is forming beyond 2F2. It is real because I have taken it on the screen. It is enlarged in size and inverted also. Okay. Again I am changing the position of our source of light, or you can say that the object. I am placing my object at F1, means on the focal point. Now I am adjusting the position of the screen to get the clear image. See, here the image is very enlarged in size. Okay, it is inverted also. Okay, and it is very far away from the optical center. We can say that it is just forming at the infinity. Okay, so we have dimmed the light for you. See, the image is very enlarged in size. It is going out from the size of the screen, and this point is approximately considered as infinity. Now I have changed the position of the object between optical center and focus point. Okay, now I am adjusting the position of the screen to take its image, but here on the screen only the boundary of the lens is shown. But if I see the image inside the lens, then there is an image that is erect, okay, and enlarged in size. So this is the type of the image that cannot be taken on the screen, so it is a virtual image. Okay, It means what we have get from this activity, that if we are changing the position of the object, then our position of the image also changes. If we are taking the object from infinity towards the optical center, then our image is going away from the optical center on the other side. Okay, but at the point when if our source is between optical center and f1, then its image is virtual and it is in the lens. We can't take it on the screen. Okay, I hope this activity is clear to you, that how we can form the different sized image with the help of the convex lens, and you have enjoyed this activity a lot. Thank you so much.